Guys, welcome to the AVoIPoE Roadshow. So what is this event about? Why are we here? So what we're showing today is really about two different types of technology, AV over IP and PoE. AV over IP, it's an accepted method of transport for AV, and obviously PoE, being power over Ethernet, you can power everything over the cables. But one thing that we wanted to demonstrate is that, one, you're capable of running everything on the same network, but also there are protocols that are required for specific requirements. So you might be able to use H.264, H.265 for one type of application, and something like JPEG 2000 over a 1 gig network for a different application. Or maybe you might need SDVoE and a 10 gig system for a completely different application. So what we're able to demonstrate for you here is an integrated solution where we've designed different zones. And we're going to go through those zones, and we're going to walk through those zones so that you can actually get hands-on and see how we've implemented the solution. Lee, do you want to go through the design a bit more?
If you want me to. Yeah, no problem. So we've got here the presentation area where we're actually using a bit of the tech. Over here we've got a simulation, but it's actually working, of a live production studio. So it's not just boxes on tables, it's working, it's running. We're going to talk through how it works with the guys over there in a little while. Over here we've got remote working. Remote working isn't all about working from home, it's about working remotely from the resources that you're using. And again, we'll talk a bit more about that later. Over here to your left, immediately to your left, it's what a huddle space might be, or a small meeting room might be, what it might look like. Far left in the corner there is what you might have in a boardroom.
It's really important that we highlight the benefits and outline why it's important.
Why what's important?
Why this type of a design is important, and the way we're going forward, it's like, what's the difference between the way that traditionally we're designing, like we're designing, a lot of people are doing point-to-point, they're sticking to what they know, might be HT-based, and they're not familiar with AV over IP or AV over IPoE, and what's the benefit of actually designing a solution like this for any of these zones and scenarios that we've created?
Well, I think it's pretty obvious, I'd have to say. AV over IP, everybody's familiar with it now, I think. Most people, at least, are familiar with AV over IP. It's been accepted. It's the accepted method of scalable signal distribution in a facility. The next logical step is, well, you know what? We're running these cat cables to throw our signals all around the building, the facility, the campus. Why don't we use those cables that we're already running to run the power as well? So then we don't have to get the Sparkies in and wait for them to run their cables and do their testing. We don't have to go to the expense of running those cables, buying them in the first place. We've got cat cables running all over the place. That's exactly what we're going to do. There's no option to not have them. Let's use them for power too. That's a really important change in the thinking. If we don't just consider PoE as an afterthought, which is what happens at the moment, it's usually an afterthought. But if we have PoE as a design choice, you will find that you're going to save energy, the first thing, because running on PoE, there are limits to the amount of power PoE can provide. So by its very nature, you're going to be using less energy because the devices running on it have to be far more energy efficient. You're going to save time during your install, but also in maintenance and so on and so forth. Because you're not, first of all, you're not waiting for the electricians. So you don't have to have that first fix, second fix rigmarole when they suddenly don't turn up because they're on another job and blah, blah, puts the whole project behind. You don't have to worry about that. You're saving time there. And the first two lead you to saving money because you're using less power. It costs you less to install in the first place. You're saving money. That's why.
Let's go through the zones. So the reason we were on this part here is that we wanted to just go through the zones first so you can familiarize yourself. Obviously nothing looks like they're supposed to look. This here is supposed to be a boardroom. This here is supposed to be a huddle space. Behind this pillar here is supposed to be remote working. Hi. And over here, we've got some digital signage going on. And all the way on the other side, besides the guys that are recording us, are the, if you guys follow me? Follow me? It's like an adventure show with a sci-fi. We've got Mark and John. This is the production studio. Lee, where are you?
I'm over here.
Ah, so Lee,
Yeah.
should we go through the way that you designed this, why you designed it the way that you did?
Well, we can do if you like, but then we're going to have to walk everybody right back to where we started.
Let's go back to where we started.
But before we do that, what we're going to do, we're not going to bore you, well, hopefully not going to bore you with too many details, but we want to answer three questions, which are, what is it? What is it? Why is it here? And what's the benefit? Really, what we're asking is, why should you care? And that's the question that we want to answer. So, Sia's told you about all the different zones, but the thing that ties all of this together is the network. So, we're going to go and have a look at that network switch rack in the corner over there, because I'm sure none of you have ever seen a network switch before. And we'll get somebody from Netgear to come and answer some questions. There we go.
So what is it? Well, this is some of our network switches. Essentially, this is what everything's connecting back to. What is it doing here? Well, this is sort of the plumbing, as you'd call it, of everything. So everything you see here is plugged into here to get power and also to get connectivity. So everything essentially is coming back to one central point, and this is doing all the switching and networking. So what's the benefit of having this here? Well, these are Pro AV specific switches. So what differs from these switches to your normal network switch is that they're optimized for AV over IP. So things like multicast, IGMP is all standard, and with the ease of setting up profiles on them. So for example, for this network where there's probably over 100 devices, all from NDI, Dante, all different protocols, they're all coming to the same switch. We've got one profile, so there's no VLANs, nothing complicated. And I mean, you can ask the people who helped set up here, and it was probably the simplest part of getting everything set up was plugging everything in one profile, and haven't run into any issues with it. So very simple, very easy, and optimized for AV over IP. We've worked with pro partners and vendors in the industry to get these switches working with all the equipment that you see here and more.
Lovely, lovely. Okay, so now we understand how the network is working, and that's important. Why? Because it's the infrastructure for everything else that's working over here. After the infrastructure, what we're going to go through next, Lee?
We've got one facility-wide thing that we haven't really spoken about, For example, we got some cameras up here. These are room cameras. They could be your CCTV system. We've got more cameras over here. We got them dotted around the room. And they're actually being used in the live production, the real live production, the one that's streaming out onto the internet right now. Things like this are being used. And we've also got some things that you might use in a facility that's not really a meeting room. It could be corridors. And that's digital signage. So I think what we might like to do is talk about that first.
Drew.
Where's Drew?
Wherefore out there? Where's my...
He's behind you.
Oh, thank you very much.
Drew, tell me what's going on here.
Over here we've got some various screens from Thin Labs. This is Jagdesh from Thin Labs here, who's provided the hardware today. So these screens, the 3x1, the touch screen over there, these are PoE devices. And we have embed signage software running on all of these, showing how you can use it in various scenarios. Talking about the integrations with external sensors, peripherals, etc., for more engaging interactive experiences. We have a PoE Pro DVX tablet down here for screen control. So this can be spitting out TCP commands over the network to change content on the screen, or it could be turning screens on or off, etc. It will run through embed. And on the touch screen over here as well, if we go back to some of the other content, we also have some what we class as your traditional digital signage as well. And this will be taking in some HLS streams too, so you can stream live into zones on this signage as well. Things like bright zone players, you can do PoE and also do UDP streams as well. And this is just trying to highlight some of the ways in which embed signage can be used in this AV over IP, PoE kind of setup.
Lovely. And Jagdish, tell us about your Thin Labs PoE devices, because there's something special here, because what I can see here are 3 displays, but I can see 1 cat cable going through there. Can you explain this a bit more about this?
See, normally what happens is you'll find that most desktop computers draw with 3 screens with the power of the CPU that is there, draws over 200 watts. Now you have 3 screens running an 8-core system which draws just about 70 watts. So when you have a large number of screens, you save a lot of money on power. But more than that is that you have a clean setup and you're able to transmit and run from a security perspective rather than wireless. PoE is a far more reliable mode of transporting data and power savings. So the largest screen that we provide is a 55-inch screen, which is PoE, but we provide right from a 15-inch screen all the way to 55.
And what's the resolution on that 55?
These are all HD.
HD, okay, 1080p.
Yeah, all 1080p, full 1080p. You can't use it for high brightness screens, but anything within in an internal environment, these could be used.
And I saw, Drew, there, you've got a touch display as well, so you've got touch enabled in the display.
All of them could be either touch or non-touch. So right from 15 to, we sell primarily not just into AV over IP, but also into manufacturing, into healthcare, and so into various verticals that these are used in, and more in a 24/7. We have over 30,000 of these PoE devices in the industry, and we've been supplying it for the last 6 to 7 years.
So over the use of, let's say, these products, how much energy is someone going to save installing these devices over, let's say, a normal desktop?
On a normal desktop, you'd be saving roughly about 75 to 100 watts per device.
75 or 100 watts per device?
Right, because when you look at a normal desktop, just the CPU draws, or when you say power, when they talk about TDP, it's thermal data, but the actual power consumption is higher. Now in PoE, it's not that way. PoE just delivers a certain level of power. So the actual power consumed on these devices against a regular desktop would be roughly about 100 watts different, because just a monitor draws 25 watts, and then the computer would draw about 75 to 100 watts. And here, the entire computer with the monitor draws about 25 to 30 watts.
Wow, wicked. All right, thank you. Let's move on.
Thank you.
Yeah, so let's stay in the zone though, in the facility-wide zone, because I touched on the the cameras, the facility-wide cameras. Now, we're sending NDI from those cameras, and we're actually streaming out live on the internet now with that, with those NDI streams. But we've also got connected to those cameras some more, let's say, performant methods of moving pictures over the network. Namely, we've got some Wirestorm SDVoE transmitters, and we've got some Matrox IPMX transmitters connected to those. Now, what might we want to use those for? And I'm going to come and ask Steve first of all. So, Steve, if we've got, let's say, for example, as we have here, the HDMI output of these room cameras or the facility cameras connected into your NHD 600 transmitters. Did I get the number right?
Yep.
Thank you. Why would I want to do that?
Well, primarily on a SDVoE, it's about not compressing the video. Most of the products that we talk about over IP are they're encoding, but they're obviously also compressing the video to send it down a 1 gig network. My thought process would be if you give yourself a bigger bandwidth, i.e. a 10 gig network, I don't need to compress my video at all, which ultimately means I've got no compression, I've got no latency, and the image is mathematically perfect.
What would the use case be for that, though? Why do I care that it's uncompressed? It's just coming from a camera.
Yeah, I mean, it probably wouldn't be necessarily the kind of product you would put on a camera because it doesn't require SDVoE performance. I mean, I could do that with 1 gig and you wouldn't notice the difference. So I wouldn't necessarily put our SDVoE, apart from, unless it was part of a larger ecosystem. So the cameras are just one part of it, and obviously I then have, you know, HDMI inputs coming from other source devices.
So sources for courses, and so you
right.
wouldn't get that latency between, let's say if you were in a school
Yep.
and you want to use another room as an overflow room, you could have the source, the feed from the cameras going into the next room, and you wouldn't have that delay going into the next room,
yeah,
for example.
it's an interesting way of doing it. So quite often we might do a lecture theatre with the full SDVoE output to give it the best performance, but for breakout rooms where that 4K quality maybe isn't quite so needed, or it's going to go out onto a 1 gig network,
yeah.
I can actually dual encode and effectively just take a lower 1 gig output from the main room and then send it onto the network as a lower bandwidth. So I can actually join these different technologies together on the same ecosystem.
I suppose the possibilities there are endless, right?
Oh, absolutely.
In the ways you can do it.
I mean, the scalability of it is obviously the main part of this, is that I can build my
it
network
is almost infinitely
asymmetrically.
scalable.
Absolutely.
Yeah. No, that's perfect. But we're doing something very similar with the Convert IP transmitters as well. What would be the differences? We could do it with SDVoE, and Steve has given us some ideas of why. Why would you want to do that? What are the benefits? But
I'd start by adding a couple more benefits,
please.
if you like. If you were streaming a medical image from one side of the hospital to the other side, because that's where the consultant was, you want to be sure that that consultant is seeing exactly what you saw on the other side. That's why you don't want to compress it. Even if you start out with grotty video, it's military intelligence video from a drone, every last pixel is important, even if they're grotty. You don't want those corrupted either. Send them without changing them. That's why you need more bandwidth as well.
That's
of course,
brilliant.
As Steve said.
Absolutely.
So just helping you out there. Yes, of course, we're using the same sort of bandwidth. The difference with IPMX, as Mark said, is we're striving to be interoperable with other things. It's not just a matter of, oh, goodness, it's a 10 gig network, that's all we can use. We're on a 10 gig network here and we're using 2.5 gig. Yeah? Use what's there. That's one of the premises of IPMX.
Okay.
Mark mentioned lots of different codecs. If you use lots of different codecs, you can be interoperable with other people who are using them. You don't end up in a single silo. Pick up on another point of Mark's thing about redundancy. Thank you. Notice we've got 2 network ports. Why have we got 2 network ports? Put yourself in one of Anna's conferences. It's COP27. Absolutely crucial the AV doesn't go down in the middle of the keynote speaker. You have 2 networks. If one fails, it switches seamlessly. That's the redundancy that Mark was talking about.
right. No, that's brilliant.
And in terms of the latency, I'd encourage anyone who comes in here, look at the latency from the camera to the top screen here.
So we will be coming around to this bit in a bit. But that was brilliant, Rob.
Thank you.
Rob Moody, absolute mine of information. What's next?
Yeah, do catch up with Rob. If you want to speak to any of these reps, go up and speak to them. They're happy to show you anything that they've got here. There's so many new things here. Just go up and ask the questions of any of the reps that are here. Where are we going next? We're here to the huddle space. So what are we doing here? Are we talking to Matt?
We are talking to Matt here at some point, but we're
Hiya.
talking to everybody really, because everybody's here. Hello, Matt.
Yeah,
How you doing?
hello. Good.
Yeah. I mean, so let me just explain a little about what we're doing in the huddle space. It's supposed to represent a huddle space. Now we're using, as the room PC, one of the ThinLabs touch screen all-in-one PoE devices here, as the source, as the machine that you're going to be using. Oh, there we go. Yeah, thanks. Imagine you're editing some video or something like that in your huddle space. Now, I wouldn't design this for a real world scenario, because what I'm doing, I'm taking the output of this PC through a DA, and I'm putting that into 3 different IP encoding systems using 3 different codecs, and I'm also putting out onto another display. Would I do that in the real world? No, I wouldn't. But we've done it here to demonstrate that we can encode into SDVoE, NDI, IPMX, all of that going out on the same network at the same time, and it's not a problem. Many people are scared. They say, oh, you can't do that with that. Oh, I wouldn't do that if I were you. We're not sure if that will work. It does work. It's just IP. It's just packets. So from the source, we're going through the SYDA. Now, the SYDA, really cool. It's not a PoE device. But that doesn't matter. It doesn't have to be a PoE device, because if you look at this box here, we're using a PoE splitter. So even though the DA doesn't natively take in PoE as a power source, it takes in, I don't know, what's this, 12 volts DC probably, from a splitter. Now this splitter, it does what it says on the tin. It splits the data element of a PoE cable thingy from the power element. And all we're using here is the power element of that, because the DA doesn't require any network connectivity. From there, we're going into the various encoding devices and splitting that out onto the network. So any connected device in this facility can make use of the signal that's coming from this source. Matt wants to say something.
Well, pretty much I can just kind of like explain you what we are doing here as a CDA, what we have in a system. So pretty much we have our G265 4K RTF around the network in different spaces. So in a remote working area, we have one transmitter. Here we have another one, and then we have a receiver in a boardroom. So the receiver obviously outputs everything on the screen. So if you can have a look on the screen, pretty much it works in that case as a multi-viewer. But what it can do, it can power up the video walls, LCD walls, LED walls, you name it. And it's pretty much very, very flexible. So I have RTSP signals on a network, and I can decode them. If they are coming from my box, the CDA box, what I do, I have like a live preview. If they don't, then I just have a signal without a preview. But you can display them whatever you want onto the video wall, screen, LED wall, whatever you want. And on top of that, what I can do as well, I can control like another third-party devices. So we have cameras here on a network. For example, one in a remote space, and obviously I can, with a PTZ camera, I can simply rotate it. On top of that, we have other stuff on the network, like we have our friends from Embed. I can simply change the input, whatever they have on the. So now it should be changing on the screens. There you go. If you just point out on the screen, it's gonna. So it's allowing you to control third-party devices as well. And what's cool about it, it's fully customizable, so you can, well, pretty much design the interface whatever you want and however you want. Cool.
Lovely, thank you. So coming back onto the boardroom area, we've got SY Electronics. Sirius, tell me about the Wizard. What's it doing here?
Wizard is a wireless sort of, sharing device. You can basically allow up to 16 people in a boardroom area to be able to communicate with each other, present what they want. Up to 4 people at the same time can show their products or their presentations on the same screen, or individually, doesn't matter. So it is a very powerful little device. It's a small, neat, PoE driven. You only need one RJ45 to drive it, end of the story, right? It's got 2 networks. Should you wish to sort of, have your data and your control separate, etc., as guest stroke, sort of, host. It works well with other devices. In this particular case, it's being fed into our Apollo 41. And Apollo 41 allows you to do seamless switching, allows you to effectively have a triple view of different HDMI inputs. They're all wired. But as a team, as a system, they obviously fulfill a requirement that much better, that much easier.
So that's like a KVM functionality on the
this particular one is Apollo 41U, whereby it's got, yes, you're absolutely right, it's got full USB capability as well. So USB, that's USB 2.0, right? There's a different version of this Wizard as well, right, which is Wizard 4U. That one has got bi-directional USB capability. So if you're talking about, let's say, some sort of a camera, etc., it can feed back to your system. So if you're working with Teams or with Zoom, situations like that, you can share your resources a lot more effectively using the Wizard 4U.
That's brilliant. And I see, a lot of Yamaha kit here. Scott and Reese, I know you guys have been working really hard, and I've seen your solution. I love the solution. But what's so special about what you've got set up here?
Well, it's on, good. Well, we're a completely Dante enabled device, so everything is powered over Ethernet on a single Cat5 cable, so everything apart from obviously the charging tray. So all of the audio, routing, control, power, etc. is all done over a network. So we are a completely IP-based system. So all of our audio, control, and network, etc. is all over Cat5, Cat6 cable.
And one other thing I notice is the tracking, working with the guys at Ava. Bally, come over here, mate. What are you doing hiding in the corner?
Hello there.
Do you want to do the demo?
It's a bit noisy, but we can certainly give it a shot.
Be quiet, please.
So at Ava, we've developed a software that works with third-party microarrays, that works with a Yamaha in this scenario, and it takes our Pro AV cameras. It's an IP-based solution. So you simply pair up on our software the mic and the camera, and you have your default channels. Depending which channel is active, the camera will move to those defined presets. It's a bit noisy to do this because there's so much echo in here and stuff, but what we like to do is show you this demonstration. When it quiets down later on, we'll have it set up showing how the different channels will work.
Sure, you can individually show that to
Absolutely,
everyone. Okay,
not a problem.
Brilliant. So essentially camera tracking situation that's working with the audio, so you're able to, let's say I'm here in this room and I walk over here, the camera will track me as I'm kind of walking along.
Yes, we have two forms of tracking. So we have motion tracking with the AI built into the camera to do motion, no need to talk. But then the PTZ Link software that is on demonstration at the moment is working with the microarray Yamaha, and then you move to presets. So depending who is talking, which part of the room, if it's a boardroom environment, who is sitting in which location talking, the camera will zoom into that preset.
And Reese, microarray up there. Obviously, that's not going to be what it's going to be like normally. What is that supposed to be representing?
So a lot of people, when we bring this demo rig out with us, ask why we bring a shower head with us. And as you say, it's not actually what it normally looks like. So this normally would be in a ceiling, so it would sit flush. Or alternatively, you could have it wire hung or on a VESA mount if you want to, depending on the install that you're looking at. But this represents a pickup of approximately 50 meters squared in terms of microphone pickup. It uses 64 capsules in a spiral pattern, so it means that it's giving you the best radial coverage you could possibly get. And it's got 4 what we call beamforming mic tracking arrays within it. So they will locate and focus in on people who are actually speaking within the space, and then it will utilize that technology to make sure it's focused in and cutting out any kind of background noise as well. And that actually is how it works together with the AVA camera side of things, using a proprietary Yamaha technology called HVAD, which is human voice activity detection. It will basically pick out whether it is or isn't a human voice. If it is, it will give the camera the information to actually point in the direction of where that source is coming from. And if not, if it's someone scraping a chair or something like that in the background, it won't start swinging the camera around to try and lock onto that sound. So relatively intelligent, yeah.
Pretty intelligent, more intelligent than I am anyway. So I want to come up to Matrox. Where's Rob? Rob, wherefore art thou? Now, so Rob, I want to talk about standards.
Yeah.
Because I think this is what really defines your Convert IP. Tell us a bit more about that.
Okay, well, I think in the world of the internet, we've all got used to plugging things together and they work. And we like that in AV as well. And it's just never happened in AV over IP because nobody's been pushing it. And that's what IPMX is trying to do. It's trying, as I say, to build bridges rather than build fences. Folks normally expect manufacturers to stand in front of somebody and say, we are better than them because. And when they hear us say we're inviting them in because we want them in, it sort of says, well, why? Well, because we want to be interoperable. There's so many benefits to being interoperable. That's what it's designed to encourage. And the IPMX standard is working towards that. It's not owned by anybody. It's an alliance. That means it moves slowly because you have to get agreement.
So it's an open standard?
It's an open standard, yes. So the codecs that are inside it, yeah, they're open standards. The JPEG XS codec that we're using here today, that's got an ISO number. That doesn't belong to anybody. And it's that's the whole premise of IPMX, is let's do things that are easy to implement, that everybody can do without ending up with a silo.
And tell me what's unique about Convert IP.
Convert IP is unique for the moment because it's the first product to actually take hold of this IPMX standard and do something with it. So the slide that Mark put up showing you all the different possible bandwidths, this will do uncompressed if you've got a 25 gig network. This will do lightly compressed if you've got a 10 gig network. This will do moderately compressed if you've got a 1 gig network. So you're not tied to anything.
So let me pose the question. If I have an HT-based C system and I want to connect that HT-based C system onto the network, theoretically, I can do that with this.
Absolutely. Now, one of the things that HT-based T themselves would say about their own standard is it doesn't work on the network. Yeah, it's not a network protocol. So what IPMX has done, what we have done with Convert IP, is say, well, if we can bring that into the conduit, once it's in the conduit, we can take it wherever we like. It's the network. So now, HD-based T is a network protocol.
So by that same thing, that's any protocol, any of these proprietary protocols can then be added to the network and work in an open standard.
So at that point, at the hardware level, we're talking about the connector primarily. So the Convert IP is quite happy with an HDMI connector, or an SDI connector, or an HD-based T coming in on an RJ45, and in principle, DisplayPort or anything else that's got its own connector. We haven't launched all of them at the very start, of course. Got to start somewhere, and starting with 3 different ones is okay. But in principle, this is a bridging technology that will move your AV from where you've got it to where you want it. And routing is what it does best. That's something it's inherited from the broadcast world. So it's made I want that source over there as simple as saying, I want that source over there, rather than cutting and pasting IP addresses and.
And how far away are we from actually having, let's say, an HC-based T module that will fit into this?
Right, so where we are as of this day today, all standing here in Manchester, the HDMI boxes are shipping. The SDMI boxes will be shipping by the end of this month, all being well. And HD-based T will be with us and certainly shipping before ISE. I hope to see it before Christmas. But yeah, we know there's some realities in the world. But yeah, this is something that is moving now. This is not something for 3 years' time.
That's brilliant. Thank you very much, Rob.
Thank you.
Lovely. I think it's time to move on. Right. So we've done the boardroom. I think we're boardroom to death with that. Thank you. But now we're going to talk about remote working. So I mentioned earlier on that remote working isn't necessarily working from home. And it's more about working remotely from the resources you're working with or resources you're consuming. And Ian looks very surprised that we're coming over to talk to him at the moment.
Ian, you're an IT company. What are you doing here?
That's a very good question. Do you want me to stand up? Yeah, so I'm representing ASUS today, but I'm from the server and workstation division, which may come as a surprise that exists to a lot of you. So where we fit in is, and it goes back to the sustainability talk from earlier on. You look at the cost of, in this case, what we're showing here is content creation. So during lockdown, people had to work from home. The average high-performance workstation has 2 pretty powerful GPUs in it, CPUs, blah, blah, blah. So you end up about 1,200 watts. So if you've got 10 content creators, it's quite a lot of power. So what we've seen the move to is, on the server side, we have things called GPU servers. So in the case here, we're running this off of a server in Taiwan, where there's 4 GPUs in that. So immediately you've lost the cost of 16 GPUs. But you're also looking at a massive reduction in power. So it's 2.2 kilowatts you're using for 10 people, as opposed to 10 times 1,200.
Did you just say a server in Taiwan?
Yeah.
Let me see the latency on this.
Sorry?
Let me see the latency.
Oh, Owen's driving that. He's just nipped to the loo.
Okay. I'd like to see how quick you can actually do, because something like, obviously doing video editing.
Well, this render thing on Cinebench is running in real time on a session to Taiwan.
Okay.
It's running on the server in Taiwan. It's not running here.
So if I understand this correctly, you've got all of that power in your server room or wherever you've got that in Taiwan. What about all this stuff? What's that running on?
So that's a good point. Yeah, so these are running on, they will be PoE in next quarter. But they are small 20 watt, so that's an AMD based mini PC, like a Nook. So small you probably can't see it. And there's the Intel one there. So they are 20 watt devices. So from the, whether it's at home or remote location, you're moving from 1,200 watts to 20 watts. So
all the front end stuff is all PoE.
Yeah.
And then the power that you really need is, and so I'd imagine, let's say, a scenario where you've got, what about classrooms? How can that be implemented in a classroom scenario?
So so we've got a case study there running. Again, the pandemic drove it forward. We've done projects before, but then suddenly we had a huge number of projects we're running. how can one put this politely? Some people's little darlings may not be that gentle with expensive IT equipment, but a cheaper, lower powered system is a lot more cost effective for education and has a longer lifespan because it doesn't, you know, ruggedized one, they last a lot longer. And again, schools, especially now with the cost of power, massive reduction in their power footprint. And just going back to the servers for a second to touch on that, as you'll probably know, CPUs are now going up to sort of 400 watts each. Video card, you know, the GPU cards, 400 is not uncommon now, 500 on some of the new ones. Generates a lot of heat. So we're, in fact, we're the first manufacturer to fully support submersive cooling with warranty and everything. But we're having a lot more people putting those into a submersive tank or liquid cooling them. So of course you can then harvest that heat off of that to drive other things. So there's a sort of secondary cost saving and an ecological, you know, plus as well. So, it's right from your PoE end of things, right the way through to the back end, because obviously we're the people you don't normally see, you know, the sort of relative that you don't talk about at, you know, Christmas parties and things, because we're in the background and not seen. Yeah, the whole chain is, I think, a lot more closed than it was until recently.
So I think what you were saying there was really about you have the low end, really low powered devices in the classroom, but in the back, in the data center, in the server room, or in let's call it the cloud, you've got that massive amount of power.
Yeah, exactly. I mean, in this case study there, the schools are running Celeron powered Chromebooks. This one is a Celeron Intel unit. That one's a AMD Ryzen. But all, obviously, they're the mobile ones to keep them down in, you know, to that.
I think the point that you touched on there, though, about harvesting the heat that's generated, you couldn't do that, but you can harvest the heat that's generated in the data center. It's a much more controlled environment.
Well, no, it's easy. Yes, you're quite right. It's easier, but there's a lot of standardization now in servers on liquid cooling. So it's a lot easier because those servers, if you're liquid cooling, that will be in a room somewhere, because obviously you wouldn't be able to hear the teachers because servers are quite noisy. But submersive cooling, where you've got a bath, we could have one running here with sort of 10 servers in it, and you wouldn't know it was on. They're that quiet now.
I'd love to see one of those.
I can arrange that. I can arrange a visit. We've got a data center not too far away. Yeah, we're continually, they're very nice people. They're continually buying servers and putting them in there.
It's a date. Okay, thanks very much, Ian.
Thank you.
Everyone will be able to speak to Ian shortly in the free-for-all that's a bit later. But I really want to just explain very briefly how this fits into the system that we've designed. You know what we've done? We've done pretty much the same that we did in the huddle space. We're using Ian's little Nook that's driving a extremely powerful server in Taiwan. We're using that as a source. We're running that through a DA, and then we're spitting that out onto each of the networks that we've got here. We've got the SDVoE, IPMX, NDI. We've got H.264, H.265 working through the Tascam and the Cedar boxes. But I've got Chris from Tascam here that I want to have a quick chat with. I think Sia likes doing these things too. But what are you doing here?
Well, we're here showing a few Tascam products that feed audio into the network, Dante boxes with DSP treatment. So they're localized DSP, very efficient, very power efficient as well, all powered off the network. And our VSR 264 and 265 units are low bit rate, meaning that these boxes can not only get feed, say, from that camera to that screen in the boardroom, but they can also deliver it to over the web to YouTube, to another decoder somewhere else in the world, which isn't normally the case for some that say an SDVOE. Is impossible to do that. So there's different, and they can also record it at the same time, which is, again, most of the boxes here are not doing that. So this could be recording that boardroom presentation for reuse later.
I think I remember you told me once that you can also live stream straight from these things.
Yes,
straight out
they
onto your
live
platform.
stream straight to YouTube, Facebook, Wowzer, any of the online, restream and all
And
that
I think
kind of stuff.
you touched on kind of on my next point, but I think maybe not everyone really picked up on it. You can't do that with SDVOE. You can't do that with any of the other products here, actually.
No.
You've got a really low bit rate, which enables that WAN, the wide area network experience.
That's the major difference between this. There's different flavors of AV over IP for different requirements, and this has one where you can go, simultaneously to the web and across around the network to another decoder. So I've got them set up here. This one's encoding, one over in the boardroom is decoding, the one in the huddle space is encoding that camera and decoding to go into the NewTek, the TriCaster.
One of the other things you mentioned was the Dante encoders. I mean, if we look just over there, we've got a gooseneck mic that you've brought along with a silver box sitting next to it as well. And that gooseneck mic isn't an AV over IP mic. It's not a Dante mic. It's a normal analog mic, isn't it?
Yep.
But how are we getting that, the audio from that mic, out onto this Dante network that we've got running all around
So
here?
it runs through our DCP. There's an MM2D, one of our Dante compact processor range, and it's got remote controllable preamps that I'm operating from my laptop over around the network. It's got DSP, it's got equalization, so you can use it for room treatments, and you can use it could also drive some traditional speakers if you want. And it's got analog outputs as well.
Wonderful. Thanks. Thanks, Chris.
Thank you.
Okay.
And I just want to give a shout out to Alpha Live. How you doing, James?
Yeah, good, thank you. How are you?
Yeah, good. What are you doing, mate?
Currently producing this.
All right, wicked. Ryan, don't hide. How you doing?
Oh, so I was completely miles away then. I'm great.
How are you finding the system that we've created?
It's mind-blowing. It basically brings two worlds together, a physical world and a virtual world together seamlessly.
So we've got a hybrid event, really.
It works perfectly, yeah.
Thank you.
We're going to move over to the production studio side of things.
Mark, you like to talk. Tell me about all this new tech stuff, because what you were talking about earlier on was really interesting from the point of view, because a lot of businesses are now looking at production, what they want to be able to do. Tell me about this new tech stuff. Tell me about the TriCaster. What am I looking at?
Okay, so we've got one of the higher end TriCasters here. So this is essentially a studio in a box. So it will switch multiple sources together. It provides effects. This particular one integrates Teams, Skype, and other conferencing systems, bringing them into that environment. Here we're generating a virtual set. If we look up here on the right, so in this case we're taking a single talking head of a person and putting them in a news studio. So we can do an awful lot here to make your run-of-the-mill videos just look better. So part here is that we can bring your branding into the program, so you're not just staring at just a presenter, you're looking at something, again, more televisual, that looks and feels, more natural for a program, that keeps people's eyes on the screen. We can also do live streaming out of this, so this will go out to a Vimeo, a YouTube, or wherever you want to go directly. It will record video, it will play back video. It is a complete studio in a box. A few years ago, this would have required a rack of equipment, and we're doing it inside a few U. These start in a small system, the minis, from a few £1,000s upwards. So, as I say, this is a relatively big unit here. We're driving this with quite a large panel, a two-stripe panel. But actually, this can be driven directly without a panel at all. It can be driven from macros. You can fire off Crestron commands to it. It can be use a remote panel that you design yourself using HTML. So we've got systems, for example, in a merchant bank, in an investment bank, where it's not driven at all, by this big complicated system. Someone comes in, they press a button to start the show, and away it goes, and it runs all the macros required. we've got a system we're working on in a minute where we're driving one of these for a stream deck. I think they've been mentioned a couple of times before, but a small, bunch of buttons, and away you go. Most interesting recently with these has been the integration, with Teams and Zoom. So if we have any, a grid or individuals, it isolates the head, the talking head in each one of them. It takes the audio. It knows who's speaking at any one time, so it can cut that audio up. It can also give talkback to the person on the other end of the Zoom call, so they know what's going on, they can hear themselves, they can get cued. So, in terms of a corporate environment, we want to be able to bring any source in from any place and mix it like we are making any other program.
And that's exactly what we're doing here, aren't we?
Exactly. So here, we're running multiple cameras around here. There's Ava cameras. We've got Newtek, Sharon's. We've got a variety, RGB Link, all coming into the same place, all on the same network. They're being powered directly off of the Netgear PoE switches, so single cable to each camera. These type of cameras are PTZ cameras, pan, tilt and zoom cameras. This particular one here is a full 360 camera with no end stops. So that can be used in quite a lot of interesting applications that we couldn't physically fit a camera in before.
Like my bedroom.
Let's not go there.
All right, I can see a lot of Tascam stuff here. Chris, tell me, this looks like the old MPC. What is it?
Okay, so this is a relatively new product in the last year. It's a Tascam Mixcast, which is a little mixing and streaming unit. So it's essentially got 4 mic inputs. You see these mics here. It's got sound effects built in. Okay, all kinds of things like that. It will record at the same time. And what we're doing here is we're powering it from a PoE splitter, so it is powered off the network.
Okay.
It will connect to a computer with multiple streams of in and out. It's also got an inbuilt recorder. So we use it as center of what could be a little production studio. It could be a round table presentation. And it's a very good quality, high quality. It's got DSP processing built in, so you can add sound effects, you can add equalization and things.
Do you know what this reminds me? When I was younger, I used to make mixtapes. Reminds me of the Porto studio, but for video.
Well, this doesn't have any video connections, but we can feed this through the network into the video switcher, the TriCaster. But yeah, it is like a little Porter studio because it's got recording. You just plug an SD card in the back and you hit record and off you go.
Yeah, I think it's like a self-contained little unit, so lovely. And then the mics over there, they're quite popular in podcasting as well, aren't they?
Yeah, these are our TM70. We've got TM70, TM80 microphones. They're quite well used in podcasting.
Lovely.
And this can also comes with software, so you can Mixcast editor that you can produce and finalize a podcast and upload it. So this is for live production and for podcasting.
Okay. And do we have Genelec here?
Just behind it.
Hi. How are you? I've heard a lot about these.
Tell you a little bit more about them.
Tell us.
So this is our Smart IP series of monitors. For anyone who doesn't know Genelec, we've been manufacturing loudspeakers, reference audio products for about 45 years, and our pedigree is in broadcast, music post-production. So with that in mind, what we try and deliver, or what we aim to deliver, is neutral audio that translates. So not only for content creators, be it Apple, Netflix, Sky, what they will use it to do is to create content, but we need to ensure. Yes? Cheers, thank you. We want to ensure that any decisions that are made with our monitors translate to the home environment or to wherever we're reproducing that audio. To do that, we've got a lot of technology in terms of the electroacoustic design, but also how we adapt that to the environment that they're in. So with that in mind, using IP technology allows us to deploy and scale these systems in a really exciting way. So what we've been able to achieve is the ability to take away power, signal, and separate control and feed that all down one Cat5 cable. But the real beauty of this is we're not sacrificing any of the performance. So what these monitors are able to achieve is exactly the same as our mains powered units. And the way that we can do that with the PoE budget we have available is we've got a capacitor inside, essentially a reservoir, that will store a charge. So any overly dynamic material will use that charge and then it'll replenish itself. So we're not kind of offering a light version. We're offering a version that will kind of keep up with our mains powered units. And that's been really exciting for us.
So these actually come in a range of different colors and sizes as well, is that right? So what's surprising to me is, like, as powered monitors go, you can actually drive a lot of power through these, right?
That's right. So these come in 3 sizes, and the idea behind that is we have an inherent family sound. So the sound doesn't change. What you're getting is more SPL, more low frequency extension. And the main kind of aim for these products was to go into the in-store market. So the ability to be able to fit those in with the kind of the vision of the designers and architects was a big part of that. So with the 20 and this 30 size, you've got a choice of 120 RAL colors. And we kind of see them going in all sorts of environments, corporate environments, boardrooms, communal areas. We also see them sneaking into broadcast. We see them going into education. So anywhere where you need neutral, clean audio, we're seeing these being deployed. Our goal is to make that sound familiar in whatever environment we're doing that in, whether it's a controlled environment, like a recording studio, control room, or an environment like this. You want to be able to hear that audio and go, I recognize that, that sounds familiar to me. So in a corporate environment, ensuring the intelligibility is there. Can you understand what someone's saying? Can you understand the message they're trying to deliver? Hugely important. And that's what we do.
Lovely. Thanks a lot. Okay, I think that's all the production studio stuff. So I'm going to go all the way back to boardroom stand. Tell us about the keypad.
Well, at SY, we've been designing, manufacturing a whole range of keypads for a number of years. And we've sold tens of thousands of the units. The keypads basically allow you to, they're fully programmable. You can set them up to actually drive any equipment, whether it's RS-232 based, IR, or IP based. So we've got about, 25, 30 different varieties. Each are with color LED. You can design the color to match your system as you wish. Each key can have up to 8 different layers of command levels. Not that you want to always do that, but from time to time you do. And they're one of the integral parts of most AV installations. Makes life so easy. If you want, for example, a matrix to be controlled by it, you can easily program it to do that. This particular one here right now showing is a 10-button one, but we've got some with navigation, some with volume control, and some with navigation and volume control as an example. So the biggest one in that range that we do is 10-button with navigation and volume. We've got a whole host of new keypads which are going to be released in time for ISE, and they should be that much better, that much easier to use, and with a lot more functionality. One of the main beauty about these is how easy it is to program, right? Literally within 5-10 minutes, you've got a fully functioning system customized for a particular job.
Lovely. Reese, I want to come back to you because there was a couple of these devices that we completely missed out. I don't know why, because this looked so lovely. Tell me what it is, because it looks like my little son would love playing with one of those.
Yeah, of course. So this is another element of the Odessia system. So again, the entire Odessia system all runs on PoE or PoE Plus, depending which element it is that we're talking about. and it's a completely networked audio system over Dante. So this is the latest addition to the Odessia system, which is the wireless microphones. Right. So these are license-free. They're run on DECT, so it's 1.9 gig. And the wireless access point that we have actually has a DECT scanner within it, so you can go and do a site survey wherever it is that you're thinking of using these to see how many channels it is that you've got available. These come in 4 different kind of flavors at the moment. So we have the tabletop directional and omnidirectional microphones, and then the 2 goosenecks, which is a 6-inch and 12-inch that we've got on display here as well. Lithium-ion batteries, which are all replaceable, and you can charge over USB-C, or you can obviously pop them on the charging dock like we've got here today as well. So what they do is they add a kind of flexible solution where you may not be able to put a microphone in the ceiling, or where you may want to not drill through a £400,000 boardroom table for a tabletop with a wire, for example. It gives you the opportunity to be able to kind of fit out that boardroom space.
So you guys have really thought about everything. Any type of scenario, you've got a product that kind of fits this bigger system.
Yeah, absolutely. I mean, to be honest, we see these being used in conjunction with each other sometimes as well. If you have like a top table, for example, where we've seen this in educational installs, where you may need goosenecks for the top table, but then you use the ceiling microphones to cover the audience. We've also got, for example, in the kind of huddle room area over here, we have the wired tabletop, because that's able to pick up a 3-meter radius, so you could use it in a smaller space. And we've actually just launched, as of UCX, so a couple of weeks ago, these 2 new products as well. So we have both the CS800 and CS500. They are all-in-one video collaboration soundbars. They have some Yamaha proprietary technology built into them called SoundCap I. And basically what that will do is it will utilize the AI tracking camera to focus in on whoever it is that's speaking in the space, and then utilize that to actually cut out any background noise from around that camera angle. It's 4K raw image camera that's within it with a 120-degree field of view. And the 2 different options, basically one is with an output speaker, one is without. So they're designed for different uses, from anything from kind of a huddle pod all the way up to a medium-sized meeting room. And when you get into those more kind of fully installed systems, that's where we start talking about the Odessia wireless and tabletop and ceiling, etc.
That's brilliant. Thank you.
No problem. Thank you.
And of course, none of this would be possible without these displays. Anthony, wherefore out there? Hi. Right. That's my Scottish accent. So tell me something, because what we're running here with these, there's some 55s, there's some 65s, but tell me about these SDNs.
Yeah, so I mean, everything we've been discussing today is around the network design and the transmission and the input sources and all the rest of it. So as a display manufacturer, we come in at the end point. So therefore, we're looking to decode these signals and then get them onto the screen in a nice, efficient way that will align with the design. So everything that we do with the products that we have is all around a modular concept, and we're very open to work with other manufacturers and technologies and standards. So what we have is slots on the side of our screens, compute module slots, whereby we can use SDM, the new Intel standard. Some of our legacy screens that are still available still use OPS, but generally we're moving on to SDM. So pick and choose your processor type, run whatever content, use it as a receiver, potentially an endpoint for some of the signage partners and whatnot that you have. We're also able to do with Raspberry Pi in the same way. We use a Raspberry Pi 4. It can go in. That runs flight information displays for a lot of airports. Good security with that as well. Able to do 4K, this type of thing. And also more recently, we're able to do NDI on there as well. So BirdDog NDI will run on the Intel SDM, a specific one. So for as much as being a receiver to act as an endpoint, NDI will also allow that then screen to become an input as well. So basically anything you have on one screen can then be distributed to any of the others that have the right type of software that's in there.
And what's important for me is that it's that you know, you guys really want to work with other vendors, and you're implementing solutions so that vendors can easily integrate into your displays. How difficult has that been working with some of these? What are the challenges that you face?
I think it's getting away from the way we've always done it, and I think that's very much an AV problem. And, you know, and for people more in the AV spectrum, they've always talked about this convergence with IT, and very much like was been discussed earlier, that, you know, get the IT guys within the end user involved earlier, because normally back in video conferencing days, the ears would perk up you're going to run what on my network? And, you know, and it would become problematic. So from that point of view, more and more reseller partners that we have are starting to come on board and adopt this technology. But for the end user point of view, I think they're seeing, you know, some real benefits there to that. Absolutely no problem at all.
So in terms of the SDM, Raspberry Pi, Bird Dog, what else?
We can do HD SDI. We can do HD-based T. We can also do USB-C. Now that's quite an interesting one. As a display manufacturer, we also have a big footprint in the desktop world. We're seeing a lot of people working at their personal workstation using a USB-C from their laptop. That's then driving multiple screens. It's then reducing the amount of power supplies required at that point. So then if you're a user and you're coming in to sit at your desk and you're plugging in on USB-C and then you're going into a meeting room and you're getting all these cables and mess and 20 minutes of trying to have your meeting going, why would you not use that USB-C cable there as well? So I think you're going to start to see that become a bit more prevalent in terms of your AV designs and how the meeting room is handled.
That's brilliant. Well, I think that's a perfect way to end it. So what have we learned today?
Well, what I've learned today is actually, it's not anything about the tech I've learned, obviously, because we put this together ourselves.
Well, you put it together.
Fair enough. I put it together. I did all the work. We know that. We don't have to tell everybody, but okay.
It's credit where credit's due.
Thank you very much. But what I did learn, actually, it's more about the soft side, about how different manufacturers, even though they might traditionally see each other as competitors, how they can work closely together and help each other out. You know, we had a very short space of time this morning to set all of this up. So what did everybody do? Everybody rolled their sleeves up and they mucked in. They finished their stuff, they move on, they help the bloke sitting next to them, no matter if he was perceived to be his sworn enemy or his best friend. Everyone just mucked in. And I think that's something that I'm really taking away from this. That's probably the biggest thing. It's a nice warm and fuzzy feeling. Gives me hope for humankind.
So what I'm hearing is like a mind shift change. You know, it's about stop thinking just about yourselves and start thinking much wider than that.
The whole mind shift change, absolutely. So that's much more philosophical question. But I think really from an AV industry point of view, that also, it's about the mind shift there. The mind shift in the thinking about your design, in your design thinking, right? Thinking about the bigger picture, thinking about, I don't know, we saw in Andy's slides there, the bottom bit of the iceberg, that iceberg that's under the water, not just a little bit on the top. Not just about how your boxes can get sold into this project, about how your boxes fit into a solution that works for the end client.
And that end client to have a better user experience as a result.
It's all about the user experience. Everything we do has to be about the user experience. We don't want anybody just to shift boxes.
Okay, so we've come to the end of this. For everyone that's been streaming it, thank you very much for streaming. Our next event is going to be at the ISC show. So the ISC show is going to be held in Barcelona. Look it up online. ISC, Integrated Systems... Europe.
It's in Europe.
It's in Europe. That's why it's in Barcelona. We're going to be there. We're going to make the announcement on LinkedIn and check out our landing page for more information. So, Lee, say goodbye to the people and tell them something.
Goodbye to the people, something.
Goodbye, people. Farewell. Like, share, subscribe, boost
You sound like a YouTuber.
Yeah, do that, you know. Press that button.
Are you going to set up a Patreon account?
What's that Patreon? I mean, that's later. Thanks for all the sponsors.
Cheers,
Thanks for all the vendors. Thanks for everyone coming down.
Thanks to Alpha Live.